my name is Frank, and welcome back to my video series where I rebuild and repair FPV drones that people send in to me. So, this time I received a drone from a very frustrated owner who tried to repair it himself but eventually gave up and reached out to me for help. He told me he tried to solder something on the ESC but ended up making it worse. Out of frustration, he bought a new ESC, but he's too worried about messing it up, so he didn't want to touch it. The drone is an iFlight AOS 7-inch with a DJI-03, a SpeedyBee F7 V3 stack, and an ELRS receiver. It also has an iFlight buzzer. For those who know the AOS frames by Chris Rosser, they're great frames, but they can be a bit frustrating to build, since the arms are loose and everything gets clamped in place by the top plate. Let's get everything out on the bench and see what we're working with. My first impression is that most of it looks fine. The frame is solid and in good shape. I immediately see a few things I want to fix. For example, I want to move the receiver away from the arm it's mounted on, and I also want to mount one of the ELRS antennas in a vertical position. Right now, both antennas are at the same angle. I also think I'll design some new TPU parts for the GPS and the air unit. But first, I want to inspect the old ESC. Since I don't fully know what happened to it, I'll start by checking whether it's just a bad solder joint or if the ESC is actually damaged. The most common mistake when soldering, when a joint looks like this, is using too little heat and flux. Most often too little heat. Having a good soldering iron is important if you want good results, preferably a smart one with a sensor in the tip itself. I use the TS101 and I'm very happy with it, even though there are better and more expensive options out there. I'll leave a link to the one I use in the description if you want to check it out. To clean this up, it's often enough to just add a bit of fresh leaded solder or add some flux and then use a solder wick to soak up the old solder. The flux I'm using was sent to me by a viewer to test. It's Mechanic Nano Flux Paste and I'm really happy with it. Much less sticky than the Amtech flux I used before. When using the wick, it's very easy for it to get stuck, so make sure to keep the temperature up the whole time. If it gets stuck, you might need to apply more flux. After a couple of rounds with the solder wick, I clean up the flux residue with isopropyl alcohol and the good old toothbrush. Well, at least I've managed to get rid of all the excess solder, but I'm a bit unsure what happened here. I'm thinking of popping off the heat shield and measuring with a multimeter to find out if one of the MOSFETs is fried. I can't see any immediate visual damage apart from a bit of missing insulation on the board. Let's measure it and see what we find. The easiest way to check if one of the MOSFETs is dead is to measure with a multimeter in diode mode. Measure between the ground pad and each motor pad. You should see some resistance. If one of them reads 0 resistance, that MOSFET is shorted and fried. As you can see here, one of them shows no resistance and is clearly damaged. So I think we can call that ESC dead. It is totally possible to replace the MOSFET that's fried, and it would be interesting to test that, but I don't have a hot air soldering station. If anyone has tips for a decent one that won't completely blow the budget, drop a comment. But let's just go ahead and put the frame back together and install the new ESC the owner has bought. The new ESC is a SpeedyBee 50A V3 that runs BL Heli S. This is actually an older version, and I would have recommended at least the 60A V4 version, but since the owner had already bought this one, we're installing it. At least it supports being flashed to Bluejay, so we can use RPM filtering in Betaflight. We'll do that later in the video. In addition to the capacitor that comes with it, I'm installing an extra one. I've seen before with this ESC that it can be a bit noisy, and I've had good results with a dual cap setup. Now the dual cap setup is finished. I'm using some TPU mounts I designed to keep everything neatly in place. One of the things people struggle with the most when they get into FPV and want to build their first drone is all the soldering that comes with it, but it's actually not that difficult. The most important thing is to take your time and not rush. If, like me here, you notice the solder is a bit stubborn, just add some flux and it will sort itself out. That's it, the new ESC is in place. Now a quick smoke test and then we'll flash Bluejay onto it. For the smoke test, you can use a smoke stopper, which you can buy cheaply, or like me here, use a bench power supply with current control. The goal is that if you have a short, it prevents a ton of amps from flowing and frying your components. I've limited it to 1 amp here, and I can see that when I turn it on, it peaks at around 300 milliamps and then settles at 28 milliamps. So no short here, and I'm good to move on. The next thing I want to do is flash the ESC with Bluejay. All F4 ESCs running BLHES can be flashed with Bluejay. The advantage is that you then get D-shot and can use RPM filtering in Betaflight, so it's really a no-brainer to do it. To flash Bluejay, you need to have the flight controller connected to the ESC, the battery plugged in, and your PC connected via USB. Use a Chromium-based browser and go to escconfigurator.com, then hit connect. Pretty similar to Betaflight. Press Read Settings and check that all 4 ESCs show up. You'll also see there that they're running BLHES. Then click Flash all ESCs. Choose Bluejay as the firmware. You can leave the ESC option as it is, and for version, select the newest available one. For larger drones, you generally want the PWM frequency as low as possible, 24 or ideally 16. However, Bluejay only supports 24, 48, and 96. Since this drone has a DJI O3 VTX, I'm choosing 48. That's because the 24 Hz frequency can interfere with the gyro in the O3 camera, which in turn can prevent you from stabilizing your footage in, for example, gyroflow. Click Flash and wait while it flashes all 4 ESCs. After that, you're done and you can enable RPM filtering in Betaflight. The GPS unit is a micro GPS M8, which is known to be quite poor. To make the best of it, I'm making a GPS cable that's shielded with copper tape and grounded to a ground pad on the flight controller. This can help a bit, but I don't have high expectations for how well this GPS is going to perform. Now everything is in place where I want it to be. The receiver has been moved and I've made a vertical mount for one of the receiver antennas. This flight controller supports plugs for most things, but because of the cable routing, I'm choosing to solder everything instead. I'm not really a fan of plugs. Now, before I finalize the repair and put on the top plate, I'm doing one last check in Betaflight. I configure the motor order and direction and set up the essentials before the test hover. I also test that the O3 unit and all the other components are working properly, so I don't have to disassemble the drone again. Now the drone is fully rebuilt. All that's left is to put the top plate back on and tune it before I send it back to the owner. For the bass tuning, I use PID Toolbox and the wobble script by the PID Toolbox guy on YouTube. I think it works really well for getting a solid bass tune and dialing in the PN to D balance before I move on to filter tuning and fine-tune the rest outdoors. The script works by performing a series of sharp stick inputs, which I then analyze using PID Toolbox. That way, I can find a good balance between P and D pretty quickly. The final result turned out pretty good. This AOS frame has very low resonance noise and is easy to tune. When I flew it outside later that day, there was a lot of wind, but I still think it flew really well. Now it's ready to be sent back to the owner, and I hope he's happy with it. Thanks for watching, and don't forget to subscribe if you enjoyed the video.